Hi Ahmad, hi Umesh. I think Brandon is on the call and he's uh, attaching to something, so he'll be listening to us and up on the call. So Ahmad, welcome. Thanks for joining the call. So can you tell a little bit about yourself? I think Umesh, uh, me, and yeah, we would like to know a little bit about you and what you do around.
Yes, definitely. First of all, I would say thank you for letting me in this, weekly hours. And this is
Mm-hmm.
the first time I'm taking, and I think probably this is the first time we have the office hour as well. So
We've
excited
been having
to.
it for a while now. Yeah, yeah.
Okay.
Mhm.
So I will be looking forward to the expert opinions here. And to my background, I'm actually a hardware engineer. I do PCB designs as a freelance,
Mhm.
and I've
Mhm.
been doing it for now, I think, 3 years. So that's a brief introduction. And in the last week, I asked a question about signal integrity and
Mhm.
related stuff, and the seniors have told me just to, you know, we will be having a chat in the office hour.
Oh,
So
yeah, yeah.
yeah,
That's okay. We are all alike in the
that's it.
community. No issues. Yeah. Mostly, yeah, we can. I particularly work on that topic, and we also have some hardware experts who've been around for a while. I think Joseph, who is out of call now, but yeah, he'll be active in the chat. Be responding. So, Umesh, you have
Yeah,
something to talk about?
voice is gone,
Mhm.
sir, again.
Yeah, audio is down again. Probably you might want to do the thing you did last time. Well, we also have Yashwant here. Hi, Yashwant.
Hi.
Oh, he's been a member of Innovates for a while now. So Yashwant, we have Umesh, Brandon, and so Ahmad, Sasi over here. So yeah, I think this is the first office hour you're joining. So why don't you tell a little bit of about yourself, Yashwant?
Hey, sure. Uh, I work at Analog Devices as an embedded software engineer.
Mm,
Uh, Mainly I work on the wireless network stack for a product called
mm,
wireless battery management systems, mainly for EVs. But uh, my work kind of goes all the way from interacting with the hardware team about uh, the chip development as to how the SoC has to turn out to be, the what should be the system clock, and from details like that up to delivering the final solution to the customer
mm.
with the whole application stack and stuff like that. So yeah, I work across the verticals. um,
Very
yeah,
interesting. So, folks
yeah.
over here, I've been knowing Yashwant for a while now. So he's a champ embedded software developer. So uh, I think we'll also get his opinion and discuss around little of embedded software stuff when we go further in this uh, meeting. So yeah, thanks Yashwant. Uh, well, I think last week we discussed about IoT stuff, right? Umesh, is audio up?
I think you can hear me now.
Oh, oh yes, yes, very well, very well.
Yeah.
So yeah, last week we had a talk mostly around IoT and the design optimization challenges faced and things like that. I wasn't there for a full meeting, so Umesh, maybe a quick recap or what was the topic exactly?
Yeah. So we talked last meeting about the role of an IoT professional, like what exactly the role of an IoT professional is, because there's a lot of talk where people say the firmware. There's very thin line between the person who takes care to write the firmware, which basically categorized as an embedded engineers in industry, and then there's a cloud people who take care configuration, manage, maintain servers, maybe communication stack at the network level. And then there are a typical software developer, like full stack developers and all. So like then the question comes, who is exactly the IoT professional? What are their role?
Mm-hmm.
So we talked about everyone's opinion, like what one thinks, like what could be closest to be called as an IoT professional, right? Because there's no there's hardly you can see IoT professionals, right, to be called.
Yeah.
So the majority of discussion
Correct.
was about the integration, what our community stands for, system integration. And my opinion
Mm-hmm.
was pretty much, I guess, even the Mike has the similar opinion, like the one who integrate the hardware, cloud, and the software, application software,
Mm-hmm.
could be considered as an IoT professional or IoT responsibilities. So
Perfect.
that's
But I think Mike is pretty seasoned in this, and in one of the earlier episodes of us, he explained about his challenges and logged into roles. So, hey, hi Joseph.
Yeah, good day.
You got a still final
Thank you,
session.
bye.
Hi Sasi, you two are here this time. We read about you a
Hi,
lot
man.
in the
Hi,
community.
hi.
Well, yeah, moving on, like this week we'll mostly discuss around firmware optimization challenges and tips and tricks work around in this. So further next we'll see one of the case study from Toyota failing changes. But before that, why don't you guys who are into companies? I think Umesh has worked on multiple projects in embedded software and companies, etc. And we have Yashwant also, who will be curious to listen to and know about the opinion. So yeah, let's probably jump into it and know about probably the firmware optimization topic. Like, what are your opinions on it and any hacks you have used? If you can go back and give an instance in that case. Yashwant, if you want to take it.
Hey, hi everyone. I wasn't sure what exactly we could discuss, provided I don't know the
Mhm.
background of the audience here, because I
Yeah.
may be talking something
Mhm.
that may not be too relevant, or people might not be able to understand the whole thing. Um,
Mhm.
uh,
So here, yeah, people are more of hardware. Mostly people are into electronics and even have a hang of
mm,
embedded, I suppose. So it can be generally around like you being working in automotive domain or firmware development, anything a small instance where uh, you have firmware optimization, or what are your basic thoughts on it? How can a firmware be made more robust, fail safe, and yeah, optimized?
yeah, sure. So since people here are more from an electronics background, maybe I'll touch upon some of the SOC related topics that we deal with
Mm-hmm.
on a day-to-day basis. Um,
Mm-hmm.
so maybe I would like to talk a little bit about functional safety. I'm not sure how many of you are aware of this concept. So functional safety mainly comes into play in applications where we have automotive, aerospace, defense, and aviation stuff. For example, let's say many of us might have been aware of the satellite systems. So we know that
Mm-hmm.
when we launch a satellite, we almost have minimal to no contact after we do a launch. So once it's into the orbit, probably it's just gonna be whether it's gonna work or it's gonna break down, and the
Yeah.
repairability is almost next to impossible. So usually
Mm-hmm.
what we do is we have redundant subsystems for every subsystem. For example, if you have a communication subsystem, you'll have another communication subsystem which is a redundant one. So if one fails, then the other one would come into operation. Same way, even in
Uh-huh.
aviation, we have fail operational systems where, let's say, one critical subsystem fails. For example, electronic subsystem, probably will have a redundant subsystem which would come into operation. That is called fail operational. While in automotive we don't do fail operational, but we do fail safe, meaning even if it fails, it has to fail safely. So this has become a
Mm-hmm.
hot topic recently as the evolution of EVs, and we write and put millions of lines of code into the automotive systems like EVs and cars as premium features come into the play.
Mm-hmm.
So in that case, I would like to talk about one such thing that we use in one of our BMS systems. So we have a BMS monitoring IC to which we have a microcontroller connected. So this microcontroller is supposed to give us a fail safe, or what we say, a functional safety feature to our product. One main thing that we use here is we use a functional safety core from ARM. So ARM certifies certain
Mm-hmm.
cores that they provide to be functionally safe. So they kind of go through certain certifications from companies such as TUV, and then they kind of certify that core to be functionally safe. So one such example would be the ARM Cortex R5. So when you have the ARM Cortex R5 core, it has a feature called dual core lock step. So what that does
Okay.
is, um, the same code is executed by two cores, not exactly at the same time, with a little bit of phase difference, and then the output of
Mm-hmm.
each core is compared, and then based on that we kind of uh, give the output, and if there's a difference, then we kind of indicate that there's a failure in the system, meaning something has gone wrong, or sometimes something is not right, because the same instruction when executed by the two cores, we essentially expect the result to be the same, and if it's different, it means that something has gone bad. So we have concepts, we have safety mechanisms in place where we kind of make sure that if at all something has gone bad, what to do next. Because in many cases what happens is, let's say you have a microcontroller, you've written a program for the microcontroller, let's say you hit an exception, or you hit a fault, or let's say there is a buffer failure or buffer leakage, or let's say some memory has got corrupted. So what should you do in that case? So we have mechanisms in place to kind of at least fail safely, and not just go into some random exception and then just don't do anything. Rather than that, we have mechanisms like do a safe reset to the system so that it comes back, even though the memory got corrupted, or we have other safety state machines where it kind of tells the vehicle control unit that something has gone bad. Now go into a safe mode where the speed will be restricted, and then you would have to ultimately stop the vehicle after driving for some distance, because let's say you're going in 100 miles per hour, and then suddenly our BMS system or any other system in the vehicle fails, then obviously the car
Yeah.
just can't go off, right? So we have such
Yeah. It's
safety
a very deadly
mechanisms in
thing.
place. Yeah, yeah, yeah.
Mm-hmm. Mm-hmm. So,
That's
Yashwant, you're focusing on.
yeah,
Yeah.
yeah. Tell me.
Great, great. Yeah, there's some really valuable things which are put up. So you're stressing on having hardware and software redundancy, like be it in the processing cores, or the uh, software which is failed to which may fail, but failing in a boundary case,
Correct,
right? Or failing inside certain defined limits, right? Non-failure. So sort of it you are telling.
correct.
Great. And you're telling about the ARM's functional safety hardware, Cortex R5 being having. So is that something the feature which comes within the silicon, like within the core, or
Yeah,
like a
the so
add-on?
the safety comes with the functionality of the IP core. Uh,
Mm-hmm.
so ultimately the silicon also becomes functionally safe because it's just an implementation after that.
Yeah, interesting, interesting. That's perfect. Okay.
Yeah. Any
Umesh,
questions or any other topics you guys wanted to ask me specifically?
yeah, folks, yeah. So Ashwant, you might have heard him already. So he's pretty much into these like functional safety, writing safety critical system software. If anything, he will be up for things now and also in the community, I suppose.
Okay, thank you.
Yep. Thanks, Ashwin. Umesh, you have something around this to share? Your mic, Umesh, probably. Unmute, please. Click on that.
I think now
Yeah,
it's audible.
perfect. You sound great.
Yeah, I think slides are visible to you. I'm not able to get it because when I share, I can't see it on the front. So,
Okay, you're trying to share a slide. Is that what you mean?
yeah, so you can't see it, all of you?
It's
I'm not
not appearing.
sure. It's not there. I don't know. Like,
Mhm. Are
for
you doing it
me,
via that share option?
I can see the slide.
you can see it. Okay. So what the other people are seeing, I don't know. Because
Mm. Yep, it's up. I can see this.
so I didn't knew that I was sharing, but then
Okay. I think this is unlike
Yes, sir.
other
Actually,
platform
I
which
am
overrides
also
others.
seeing your screen.
Mhm. Yeah, me as well. Perfect, Umesh. Go ahead.
okay, all right. So it's I think this is the first time I am using this to share
Okay.
something on my screen.
Yeah.
Anyways, it was great to listen, Yashwan, and
Mm.
really I'm not in this area, but really happy to hear how the testing and all happens, especially
Mm.
in automotive, where basically you're coming from, right? And I hope we will talk more about tools and technologies that it involves, maybe very specific SOCs and sensors and all. Right now, my knowledge is very limited in that domain, so I don't have any
Mhm.
specific question or any specific point to talk. Maybe if anybody else has, I don't know.
Yeah. Well, that's all right. Saji, if you have something, uh, I think he is out of the meeting now, right?
Okay.
Joseph, do you have something over here? Or maybe, I think Ahmad also wants to know hardware, like signal integrity, power integrity stuff. So, you being a champ in that, he has put a question related to that. Uh, Umesh is sharing about it. I think it's the next question. So, this is about task motor is the other question.
Yeah, I think we have this received this question from I think Jeremy, and
Yeah.
yeah. So the question is
Have
basically
you heard
about
about it, Umesh? Yeah.
I have heard about task mode firmware, but I have
Oh.
not dealt with that very specific hardware because it's very niche and specific, right? It does runs on this ESP8266, but it has its own custom flavor task mode firmware, what they call, and I believe it's more like interface built to create some, application softwares like UI and all. That's exactly what I understood from the question. So if somebody has
Yeah.
experience on
Probably.
that, then maybe.
Hmm. I do not. I did not work on this and not have idea on this one. Probably we'll have to do some research and we'll address this in the community going further. Uh, then maybe the next question, right? I think Ahmed was asking about if my screen is visible for you. So he says he's reading a book by Eric Bogatin regarding signal and power integrity, and he is interested to consider designing high speed PCBs and interested to know what effort does it take and how to actually learn it and get practice this particular thing. So Joseph, you the other day told like signal integrity, power integrity has been thing around your interest. So if you have any suggestions or tips, why I'm not sure.
Okay. Am I audible?
Yes.
Yes.
Okay. In terms of learning high speed PCB design, yeah, it's actually going the right way. Taking Eric Bogatin's book on signal and power integrity. But one thing we need to understand also is practice. Yes, we need to do lots of practice when moving like into a new skill set. So the approach I'll tend to take, continue reading the book, but there are some there are some stops that you might actually see that you might find difficult getting a full grasp of it. Again, so one way to get like full knowledge is based on doing practice. There are some open source boards online. Like I don't know if it's a Umesh or Nabat that shared an IMX6 yes, open source board by NXP. Yes, so you can take the board, you take their schematic, you note the processors that they are using, you get the data sheet, then you start exploring. You start exploring. You start doing your simple design. You can just design a processor with an Ethernet connection. Note how you know what is control impedance. You know what is transmission lines. You know how power integrity works, how signal integrity works. When we talk of high-speed PCB design, talking of we're normally taking into account electromagnetic compatibility. You get EMI and EMC, very important. Yeah, so the things I'll actually tell you to understand when moving into this field, you need to get the full graphs of SI, signal integrity, power integrity, controlled impedance, differential
And
pair, routing. You get what else you get? You need to also understand most designers we do design electronics board without having placement of components. You need to understand component placement also, how to place components at a proper place. Most times connectors, we need to place connectors at the edge of the PCB. Even you also noise at the background. You also need to understand some basic ROF design principles. Yes, you need to understand some basic ROF design principles. One one advice I'll also give that you should that you can take
well,
yeah,
well,
transmission
okay.
line
Yeah, I can.
controlling.
uh,
Am I
Yeah.
still audible?
So, what was the last thing you were telling?
Sorry, am I still audible?
Yeah. What was the last thing you were telling, Joseph?
Yeah, I said that we need to get full grasp of transmission line, control impedance, power integrity,
Mm-hmm.
um, uh, also component placement. Need to understand component placement.
Mm-hmm.
Yeah, Joseph, that's
Great,
is a
great.
very good suggestion. And in
Yeah,
the book which I mentioned, there is a lot of theoretical prospect about all this stuff, like where comes the signal integrity on single units, or and when we consider multiple nets, how the EMI and EMC can, and even the crosstalk and the noise can come around. So I
yeah,
think for the theoretical knowledge, that book is really good. But
yeah.
I was really concerned about how practically I, the implement those things.
Yeah, so that's why I was
But
making a
yeah, yeah,
suggestions for yeah for you to like get use there are some open source board. I made example of I IMX IMX6 you get
yeah,
from
sure,
NX
sure,
you get so
yeah,
you can use that. One thing that also help is there are so many Ampton live video 2020 or 2021 Ampton live video. You see where Eric Bogatin they are actually explaining some design principles. You see Rick Hartley and so many engineers. Both are Robert Fenarick also. You get so it also help you. Then on I also have materials. I also have materials that I can share with you. You get, but that will be, let me say, when we go to the Discord channel. You get, I have materials that I can share with you so that you'll be practically oriented. You get, so the major thing is just for you to just
Okay.
get everything hands on,
Okay.
hands on work.
Sure. Sure. That will be great. Okay.
So
Yeah,
maybe
more than that,
on this,
I mean, the one thing is that I currently like around like this month I've been working in this topic itself. So mostly you can get understanding of it once you jump into the tool. For example, there are multiple providers, like tool providers on these popular ones to say maybe ANSYS Scywave, the SI Wave by ANSYS. So we can get access to this tool
Yeah.
from from an organization or educational institute or so. So this tool, once you get into it, you
Yeah.
get a very intuitive sense of how to consider different sections in a board, how to assign ports if you want to do say power integrity test, right? Power integrity simulation with uh, considering if you want to measure like SYZ parameters. So major things
Yeah.
come something like you can have DCIR, like how much drop you have once you from the source of the power to the load, right? How much drop you have in the line. So that will be one thing to in signal integrity, power integrity, to know
Yeah.
that what the station and if your trace can handle it also. And then the other thing is
Yeah.
you also have like a S parameter, Y parameter, and Z parameter. Like basically, you will get to know the impedance at the input of the reception component, like whatever you have. Say you have a DC-DC converter supplying power to a motor driver circuitry, right? So you might be interested in knowing if any other signal is interfering with that. And say you have a switching regulator working at certain like 300, 400 kilohertz, and if it would interfere with the power delivered to the motor driver circuitry. So these things can be intuitively that setup can be built in this type of tools, and they help in really getting the hang of like how can it practically be done, and these show by aligning certain frequency ranges can get a sweep and how this is. So it's just like anything like you think about software or even PCB design, right? So theoretically,
Yeah.
yes, there is a definitely aspect of it. There are certain general quote unquote guidelines to follow
Yeah.
before jumping into anything. And once you are into it, then it's a whole different thing of getting a feel of it. And once you are into it and run certain simulation, then you're able to get a gut feeling of certain aspects of it, saying, okay, while routing itself in a trace, by routing the trace itself in the PCB, you'll get, oh, this might interfere with this particular signal. You'll have to have a decoupling plane, like a booklet structure in the PCB, having ground plane signal and ground also. So yeah, I would say
Yeah.
simulation, like jumping into the tool and uh, getting hands-on in it practically will help a lot. And what those Joseph was saying, to do that, either you'll have to have your own design, or you can take like a reference design already, which is available in the website provided
Yeah.
open
Yeah.
source by these companies. So
Okay.
it's
Okay.
just all about
Navdeep,
doing.
just
Yeah, I say just all
yes,
about doing
Joseph.
projects. Yeah, you just need to do projects and be consistent. The more you do projects, the more you learn things you get. You learn how to use ports like PCIe. You learn how to deal with DDRO, also DDRO routing topology, and all that. So just get hands-on projects and be doing. I can also assist you on that. So you can just give me a DM on Discord. Yeah, I can go with that.
Oh, okay. Okay.
perfect. Yeah.
Navdeep, just one last thing from you. Can you just
Mhm.
please mention those software tools that you, because there's a background noise and I couldn't properly hear the exact names of those tools. So I will definitely take a look
Okay.
into them.
Yeah, sure. It's the ANSYS SIWAD cyber. So I'll also put that like reply over your question in the platform. Okay,
Okay.
perfect.
Okay.
All right, Aman. So now probably we'll look at one of the case studies. So I hit across this one uh, interesting study. It's probably from a little long ago, which happened with Toyota. So this is about, if my screen is up, it's a case study about an unintended acceleration problem which is encountered in a Toyota car, Lexus, and certain versions of it. And is the screen up? Just as a
Yes, I
Yes.
can see.
the presentation. Okay. All credits to Professor Phil. I am right away presenting that work over here because it lies somewhere around the topic of our discussion today. I thought like it would be interesting to show around this, and probably we'll have some discussion after like regarding this or yeah. So this is specifically about like how software can be or software or hardware redundancy is important while designing any system, and um, by taking a lab use case. So incidents like this keep happening over and over, and it's always learning for the industry, and from such reports we people can get to know and learn about. So this is quite a old incident. It's happened with Toyota, Lexus, and um, few other models of them also. Yeah, sorry about that crash. I'm showing it here, but the thing is, if we look at like what caused this also, so that has been this has been repeatedly occurring in several instances, and usually companies what they try to do is they say it was certain other issue, or one of the thing which initially was told was it was issue with the floor mat, and they had recalled certain models of car back, and then it was again uh, allegations regarding a sticky gas pedal also. Then once a thorough investigation was carried regarding this, few things have come out. So this document goes over like what could have stopped this, or what can be done in future to avoid these type of incidents. So one thing which also Ashwant was highlighting is always the redundancy in the system. So even if you generally look at gas pedal or like acceleration pedal in a car, uh, there is like second or up to third degree redundancy in that. So one is the you have the resolver which will say how much you press the pedal, and there will also be a position sensor to cross check it. So every time certain result is given, it's equated also and cross checked. If not, if both doesn't match, right, the output of first sensor and second sensor, then everything can be blocked. Software saying give priority to this, or give priority to the lowest number, or sort of it. So yeah, redundancy is highlighted uh, from the study, and then there are also certain other things. The thing is here, from the whole analysis of the study, there was, yeah, quote unquote, like NASA did not find any smoking gun. In the sense, they did not find one root cause that this is the problem and this is where the software is failed, or this is the bit which flipped and caused the crash, or unintended acceleration which led to the crash also. So this exposed a whole set of methodologies or strategies which would be like, good to follow things and open up certain aspects and understandings about what has been in the development of the software. So uh, further further in this, I'm picking up certain pairs of this slide is quite a big one. So here they say, it's a one of the studies says it's like a single bit flip that killed, or which caused this incident. So including the bugs that caused unintended acceleration. So they are linked to of course exaggeration, and then they found certain uh, bugs related to stack overflow and memory corruption. Further they go into and show why this wasn't detected in the first place, right? This one slide has a lot of meaning, or I would say why why was it not detected in the vehicle testing, right? So the plot here shows like how many scenarios to be considered for the test, and what possible tests can be designed to see failure types. So at certain point it becomes impractical to find all the edge cases and run n number of tests, right? So this is basically telling the infeasibility. But maybe if Yashwant can add upon something related to how generally in the industry the software testing is done. And I've heard there is something called like a V methodology or a V topology method of testing, where you start with system and unit tests, and then finally come boil down and narrow down towards good working software.
Yeah,
Um,
that's true about the V
mhm,
model, but I'm pretty much sure that V model is very common and that the origin of it dates long back. I think even before the Toyota incident, which you are indicating here. So
mhm,
the challenge comes where um you have a lot of software being written by hand and also tested by hand. And I think
mhm,
at this point model based development was not at its peak, and I'm not sure how far was the adaptability of standards like Autosar within the automotive industry. But I would like to add some points on how it's done today. Maybe this is long back,
mhm,
but today I'm pretty sure incidents like these uh, are very very rare. And I'll tell
okay,
you the reason why. So
mhm,
in the recent years, model-based development has gained a lot of traction. I think more or less all of you might have used MATLAB at least once. So tools like MATLAB and Simulink provide options to do a model-based development, meaning you will not be writing C code directly. Rather, you will be developing a model of the system which you want to do. For example, let us say you want to design and model the engine control unit. So you will actually put up a model of the engine control unit in the MATLAB. You will specify what are the inputs, what are the outputs, what are the conditions, what checks you have to do, and what should be the expected output. So you kind of do a model in Simulink, and the Simulink will generate the necessary code. Even within the Autosar standard, it can generate a Misra complaint code, and that would go and sit into the software component of the ECU. And more or less recently, the Autosar stack is very well tested and is widely used within the industry. Autosar has
mhm,
it is I would basically say it provides several layers of abstraction and ease of software reuse. For example, let's say you have a microcontroller from Infineon and then you have a microcontroller from NXP. Both of these are going to be used as an ECU. Let's say you want to deploy the same acceleration or the engine control unit software on the Infineon microcontroller for one car model, while on the NXP microcontroller for another car model. You don't have to modify anything in your application code or the software component, whereas the only thing which you need to change is the microcontroller abstraction layer, or something called as the MCAL layer in the Autosar.
okay,
So these
mhm,
these stacks, the Autosar stack, which they use, the basic software which consists of the drivers, the abstraction layers, they are all rigorously tested, and it's reused widely across the industry, across OEMs, across car models. It's like uh, almost, let's say, if you are going to use the same ECU or the same software stack, literally millions of vehicles running on the road from different manufacturers and OEMs, they all use the same software. And that kind of gives people a lot of confidence, because it's so much tested and it's into the existence that it's very rare that there would be a bug in a basic software component, which is a part of the Autosar stack. And this is also maintained by a consortium consisting of big players in the automotive industry. For example, the consortium is mainly maintained by players like General Motors, Volvo, Volkswagen, Tesla. I'm not sure; they're pretty new to the industry, but but majorly you could basically understand that BMW, Benz, and these people, they kind of mainly dominate this consortium. So in recent days, all this model based development, and so when you kind of do a model based development, it also generates the tests required for it. And uh, it's rarely bugs come from these kind of things. But early, when people used to write almost everything by hand, mistakes do occur. But in recent times, I would say that these things have improved a lot. But one more thing is, when we kind of look at cases like Tesla, where they have AI integrated into their self-driving
Mm.
cars and all, self-navigation. There, it's still a challenge, because you never know what comes up in the road. Let's say you have implemented a lane detection algorithm, and you have trained the model with so amount of data. You could still get into a road or get into a place where it's completely new, and the system gets confused what to do. And even in ADAS, it's the same thing. The advanced driver assistance systems, even there you kind of see that there are a lot of new cases that occur when you kind of put it into operation. So yeah, in recent days, technology has improved a lot. Bugs like these are very rare. But the thing is, how well the OEMs have adopted these kind of technologies. For example, I would personally tell an incident of mine. So there is a facility, no, there's a rental bike called Yulu, rental EV
Mm.
bike called Yulu in Bangalore. So whether Yulu also uses Autosar and all these type of model based development, that's a big question. Because I do remember that kind of it was an accident kind of thing, which I had to face, where the rear wheel of that Yulu kind of seized, and it never, even though the battery was charged, it seized in between the road, which is too bad.
Oh,
It's a bug, it's a software bug. But this is a startup company, it's a very small company, and these tools are very very expensive. So Vector is a company that provides most of these Autosar based tools for configuring the software. But Vector tools are very very expensive, unless you're a corporate conglomerate in the automotive industry, who has like millions and millions of dollars to spend on the development. If you're not that, then Vector tools might not be something that you could afford with a large number of licenses for development. So yeah, that's something where even I don't know, even Ola has a lot of these problems. But we can see that IC engines, which have been there for quite some time, they're pretty mature, and all those softwares
mm.
have were, have almost become legacy. For example, the acceleration systems, the braking systems, and the engine control unit, all these things, all these software are now legacy software. They are written long back, very well tested on road, because we have millions of vehicles running on road. But the new vehicles that are being developed, are they following the standards? Are they using the same technology? Or that's a big question. So that's something from my side.
Yeah, yeah. Great, Ishant. It was nice. You gave a in-depth description of like what's going on in the industry now and what people are adapting to and OEMs are doing in that sense. So thanks for that. And this report somewhere ends with saying, the root cause or the absolute. There is nothing one thing to point, but it is something like one led to another sort of thing, and uh, there are also instances of happening of like random hardware faults occurring in the system. Say you have like a thermal issue, or for example, this slide shows high energy neutron, which potentially causes a bit flip in a transistor, right? So this kind of thing, if a bit is flipped, then that's almost like a blunder in the complex software which is running it. A bit flip can kill a task, or create a dangling pointer which can ruin the function which is running and corrupt the system. So yeah, overall, the conclusion of this is like it, there are certain factors which is relative to each other as cascading effect. It just happened, and uh, yeah, that's what is the summary of this thing. So I'll share this document later in the group in case you're interested to look into it and uh, dig more into. So yeah, we'll probably move into next stuff. What do we have? I think questions addressed. mm, there is one about, okay, the Automotive firmware we have seen about it. Probably there is some more research required on it, and we'll address it at a later point in the community. Then this is what is addressed, and then yep, this idea has been around for a while now about the development board, which Joseph has been really enthusiastic about and has brought up. So what's the thought? Like, I think Brandon shared a really nice reference about like the Misty Sum module, uh, which is built around ES3 to S4, if I'm correct, and it mainly comes in picture while having applications related to Edge AI and vision based stuff. So yeah, Umesh, do you have anything thoughts on this? Like, have you refined stuff on it? Joseph, even.
Actually, from me, if I speak today, you might get the background noise. I'm not sure. I mean, people speaking out in my place, so they are
Oh,
working and talking. So that's why I'm trying to
right.
avoid.
Oh
We can
well.
hear you, Umesh.
Sorry,
I said we can hear you. You can go on.
come again. Like
I said we can hear you. You can go on.
yeah, but
Oh yeah.
sometimes maybe you will get because I put this headset, but this
Mhm.
headset's mic is not working actually. Mic is using internal laptops. But as far as my personal opinion goes for this question, I think it make a sense for somebody to take up this project, okay? And I mean, whoever could afford the time, maybe they could able to take this hardware because this is really capable piece of hardware. And since we want to invest our time altogether into the embedded Linux, I believe
Mhm.
this is the hardware that we should explore. Yes, of course, there may be some opinion, and I welcome that opinion as well. Like if you say, let's say, a generic device like BeagleBone or Raspberry Pi or something, but I think if we can get this hardware as a sponsor, then if we would have a sample and somebody wants to
Mhm.
try maybe port Yocto Linux and then maybe share what they learn through this entire process of booting this hardware, putting up software packages up there, and then as what been mentioned in the question itself, so this will lay down the foundation for what we are assuming for the hardware, right? There's always if you can run embedded Linux like Yocto or something with Docker image, you could also maybe write bootloader, or maybe there would be definitely because they have very well documented GitHub page and their Wikipedia. So maybe we
Then
can
yeah.
also use the bootloader and run the RTOS as well for predictive behavior, real time, if in case we want to achieve that. So I think this all goes to now, like, does somebody has really interest to put their time and energy into?
So Brandon said yeah. The thing about this question is like it's mostly not about building anything from scratch, but having like a system on module and working on projects around it, and kind of if someone wants to have help around uh, hardware OS, so it might not be relevant for all the things that people work on, but uh, just as a like we have a system on module and can get the hang
Yeah,
of it. That's
especially
why.
I think it would be useful for the person who want to explore commercial grade hardware. Okay,
Mhm,
like
mhm.
let's say if you are building Yocto distribution on BeagleBoard or Raspberry Pi, you have a lot of recipes and a lot of things ready into the Poki, right? So
That's correct. Like,
basically,
yeah,
even if you feel you are doing, you are not actually doing anything because 99% things are ready. You're just you know pulling that over the GitHub repo and then you know,
Yeah.
basically just running some commands on shell and then say, okay, I put this and I did this, right? So if somebody is
Mm.
very, very serious and want to explore commercial grade hardware and could able to face those commercial challenges, okay, then maybe this is the best hardware for that person in our community. So let's say somebody is
Yeah.
investing his time into hobby projects, and probably that guy already have an experience of, you know, embedded Linux to be running on, let's say, Raspberry Pi or BeagleBoard or something like that. And now that person
Mhm.
wants to get their hands dirty with some commercial grade hardware. I think then it makes sense, right? So I'm not saying like somebody who is a complete new and want to try it for first time. Maybe in that case, what you are saying, it's better for that person to start with very base hardware, and maybe
Yeah.
that hardware could
One
be
is.
BeagleBone, not even Raspberry Pi, because then again you end up using QMO and other packages, which
Mm.
basically makes it difficult. That's why I think even in industry, yesterday I was doing my own personal research, and this is point I think we can discuss why there are more tutorials and blogs, write-ups, opinions about embedded Linux running on BeagleBone rather than Raspberry Pi,
Mm.
or even for IMX, you see very little. So even for Open ST Linux, right, what we have already once discussed in our community, and but then when you look at commercial product, I think the requirement and the kind of software development it does is very high level, very, very high level customization for every peripheral. So, in that context, I feel that if we have that kind of person who is willing to invest his time in order to learn the, you know, full professional approach of building Linux onto, and by the way, the chip is very capable, it's from Renesas, right?
Yeah, yeah.
And
So nowadays this is happening. Like a lot of companies, right? A lot of silicon companies, they come up with their own flavor of processors, and also the application layer which runs on top of it will be alike for most of them or all of them. The base layer, like whatever low-level drivers are there, and to support packages, and also one thing which will be very important while new adopt people adopt it, as a hobbyist or as a small company organization is adopting is the support, right? So if some company will introduce silicon, then the support won't be great initially. Unlike say Beagleboard will have its open source community, will have extensive support over their forum compared to their Renesas processor, which will be getting into, and the yeah, the process of getting help regarding that will be little deeper, getting going into their forum, raising questions, and getting for the application engineer to implement. So yeah, that's one thing. And moreover, the goal over here is to build certain reference examples and show how certain challenges can be overcome in designs and yeah, things around that. So yeah, for this particular case, right, what I feel is more of whatever is available in the market, off the shelf, popular processor, like a hardware development platform hosting this processor will be more suitable rather than building one in custom or getting one which is just getting launched. Or so. Yeah.
Okay, one
yeah.
question I have: what is the
Mhm.
target application for this MIST sound? I mean, what are the target applications?
Okay, so this is like a to think it as a like a community hardware where people here will be knowing how to use it, and if certain
No,
people
no,
face challenge
no,
around it.
no, not about that. I mean, the application. I mean, in which applications can this be used? The chip in the Renesas chip on the MIST SOM. Meaning, let's say
Oh,
for
okay.
example, yeah, the Avnet's ZT1CG, that is intended for machine vision applications or ML acceleration based applications.
Hmm.
Yeah, that's what.
So So Yashwant, we are seeing this hardware as a base hardware which can be well suited for IoT use cases, and of course edge IoT device, right? Because if you check the web page, this is quite capable hardware with lot of functionalities. So IoT and edge IoT device to be seen, and then on the top of that you can build several use cases from different business verticals, right? From, let's say, agri-tech to high-end, let's say automotive to image recognition or something. So that is what we are looking for
How
here.
is how
So
is this
more,
better than, let's say, the latest version of RPi?
see, latest version of Raspberry Pi, that's what I said, like,
Mhm.
I mean, there are different contexts we can discuss why Raspberry Pi doesn't suit to embedded Linux. Okay, talking in the context of embedded Linux, because in the end, it's gonna, even if you run the Docker will hold the Linux image, right? So the problem basically with Raspberry Pi is you host the Linux OS onto the SD card, and in that goes back to my discussion, like in commercial grade hardware you never host the operating system in SD card, you have it into the eMMC, right? Memory chip.
Okay.
And so the
Okay.
read write speed is very high, which is what in industrial applications you basically needs. So if you look at this board design, it's fully designed in terms of, even now I'm not saying Raspberry Pi is not good. If you get carrier board of Raspberry Pi and then get the compute module,
Hmm.
because in compute module they also have eMMC on
Hmm.
that, right?
Hmm.
So basically the design for DIY is very different than the design for the commercial grade. What we are seeing with this hardware is the person who really want to explore from scratch the journey, right? So let's say somebody who have already worked with what I said before, like Yocto and other distributions onto this BeagleBone and Raspberry Pi. For that person, maybe this will suit, right?
Okay. But
Yeah.
being in a community where people want to learn things, it's better to have something that has a lot of community support available online as well. For example, I'm not sure how well we have community support for this Misty song, because I'm hearing this for the first time. I've
Yeah.
worked with a lot of psalms before,
Yeah.
but this I've never heard of.
Yes, yes. That's
Yeah,
why
maybe
that is
because,
there on the slide.
yeah, maybe that's
For
maybe.
everybody to see it for first time, that's why they are there. And maybe because maybe we do have some people from this company in our community. So if somebody wants to explore some use cases and maybe some GitHub repository to get the help from, maybe they will get it. But I sort of support what even Navdeep and you are saying, like if it's a community, maybe it makes sense to choose the most basic hardware. My only point was for the person who want to get hands dirty with commercial grade issues and challenges, right? Because sometimes you also need to have an experience what happens when you don't have a documentation. Like I learned embedded system when there were no teacher in, I mean nobody to train you in India, 2008 and 9, where embedded system board was wooden boxes, and I'm sure you have seen in your college days, right? That
Yes.
wooden boxes where you press move a comma 20 hex. So that is the generation I grown up. So I think if somebody is a person who wants to go there, I know nobody wants to go that way. Okay, it's painful and difficult. But if somebody really wants to go that level, then maybe that's not for everybody for that particular case, right?
Okay. Okay.
And I'm not saying like, okay, take this hardware and just discussing. At least this discussion bring a lot of awareness among people what makes the difference between the commercial grade hardware and the DIY hardware, right? I hope so.
Okay.
I'm
Okay.
not sure.
Yeah.
Well, going on, that's what we have here, and these are some of the uh, design tips and resources which have been around in the community shared this week. And further, yeah, it's open to for a feedback time. So here, probably in the last meeting, the same thing is brought up, and now if anyone wants to, see, tell what's working, what's not working, or what can be improved, then that will be a very good, point of all of us to. Umesh, you are adding something?
E- Not really much here from my side, but I would like to see more and more contribution in a community. Like maybe
Mm-hmm.
people have to be more visible and
Okay.
ask more questions and more conversation. Basically, I mean that's what I wish for personally.
Great. Yeah.
Th- Then of course, and
Ahmed,
then
I think you have
help
been.
each other to
Mhm.
be little, encouragement for somebody to post and be
Well.
communicative because myself is not very open person, when I think a lot and do very little. So
Mhm.
if the case is like me, then maybe people do need first initial push, and then maybe if the more and more activity happens, it's encourage more people to maybe someday they think, okay, let me also type and hit that button, right?
Yeah, yeah.
And
Joseph and Ahmed, if you have something, you're just here and it's your first meeting. So, if you like to see something more new or any new topics around.
Yeah, yeah. I'm just I'm with Mesh, just more conversation. If some people are going through like any design challenges or either in the hardware or firmware, they can easily share there. So there'll be contribution and engagement on the Discord channel. So that is just what we actually need now.
Okay. Well. Ahmed, you were about to say something?
Yes, actually, I wanted to say that the idea of including a case study, I really like it,
Mm-hmm.
because we all of we people are, very expert to some niche, and overall we know
Mm-hmm.
something. For example, we are talking about the firmware designing and how the redundant system can help in a better community and better application design. But you know that case study was really, what how I can put it, like it was really engaging, especially for me to get into this office or meeting. So I really like that idea, and I must say that I wanted to see a case study in the next meeting as well.
Well.
Yeah, that was a really good idea,
Okay.
Navadeep. Thank you for that.
Oh, welcome. I think thanks, everyone. I think Yashwant also had a very valuable inputs on that and gave a scenario that's happening currently and the general methodology of how the industry is changed, what are being done and what's trending. So thanks, Yashwant, for that.
yes, I think in the future I would probably expect more about MCAL and Autosar stuff from Yashwant to be part of community because I use STM32 quite a lot, and even I know there are libraries and port for MCAL, entire different stack. But since I don't deal so much into automotive, I have hardly any chance. And but maybe we can have more discussion on those specific tools, like how they use and some use cases on the coding side, little bit, and then talk about the challenges associated with it for the developers. I hope my audio is clear, right?
Yeah, it is.
Yeah.
Okay. Yeah.
Yeah, I
Okay.
think that the idea of continuing use cases is really a good one because we're all practitioners, right? So having the ability to talk about something that's real and tangible is something that you don't really find out in the wild, right? You find hypothetical and theoretical discussions of technologies out of context a lot of times. But if we can get the community, and I think this is what Umesh is sort of hinting at, is for you all, Yeshwant, Ahmed, like for Joseph, if you all have projects that you're working on, we're probably going to lean on you to bring those in as case studies to discuss here. And if you can't, if you can't speak about like specific companies or anything, that's fine. But if we can at least speak about, what you're working on, and then, try to apply our knowledge to it, I think that would be great.
Yeah, that's a really good idea.
Okay.
I think even if there is no solution, okay, for somebody facing some problem, that's absolutely fine. Sometimes knowing problem in itself is very important. I'm just talking in terms of, when you are using certain tools and facing certain problems and maybe solving certain specific uh, problem, or maybe specific technology specific also could be possible, right? So
Yeah,
maybe taking that problem in front of different people, like the way we are, could help everybody to be aware of those problems.
Yeah.
And I think maybe you don't need always to know all the solutions in on the planet Earth, because this field is really complex and very deep, wide. Nobody knows everything, and but the knowing problem might help you understand. Let's say if tomorrow you are picking up those work, prior to that, like what is that you are signing up to, right? Just my thought, random.
Yeah, and on top of that, I mean, these are recorded, right? And when we get fully live, we're going to be restreaming them to multiple platforms, so lots of other people will be able to see, and hopefully it'll have a snowball effect where we're bringing in other people who are curious, maybe have an answer, maybe don't, but at least getting other people involved as well. So that
Maybe
honestly,
somewhere in social media, somebody might be an expert or have a solution with that person might put down somewhere in the comments. Who knows?
right? It's a great idea, Navdeep. Thank you. We'll,
Well, well.
we'll
And about the timings, I think we have better participation this time with one of those people over here, and some people might not have been able to, like Jeremy was telling you, into uh, yeah outstation also. So maybe I think we have converged to a good time after the last poll which we did. It seems to be working, right? And if there's anything, please do tell. Umesh is smiling. Anything?
No, some of my employees wanted to see what I'm doing, so maybe they wants to
Oh my
join.
God.
Yeah,
Who
but
gets
they have to
joined?
assemble some hardwares today evening, so
Ah,
we have to ship it tomorrow morning.
okay, okay. And for the next meeting, what suggestions do you have? These are some topics, shortlisted topics. So, what is the majority interest here?
So, the last time, not last meeting, but the meeting before, we had a really good topic with Mike. It was just sort of general IoT device design and development challenges. So I don't know. I'm assuming it was pretty specific to firmware, but some of the considerations. This might be an opportunity to go back to that, and whatever the foundation was here that was laid here, sort of try to apply it. The things that we've discussed today. I'll go back and listen to the recording, but to an IoT design, because I feel like there weren't as many people on that one, and we didn't cover hardly any ground because it's such a broad field, right? We started talking a little bit about
Yes.
connectivity and some of the options that are available, but obviously in IoT design, there's so much more. I think Umesh, in the past, you've brought up performance monitoring and optimization for an IoT device. That might be another way to move forward as well.
Yeah. And if any topic sessions, do. So we can add on here and try to bring it forward,
Yeah.
put people forward and getting some experts for the team.
Ahmed and Yashwant, is there anything in particular that you would like to see since you're the newbies here?
Particularly for me, I think I will be more interesting. Of course, the IoT device and development challenge, as Brandon you said, it's really engaging as well. But personally, I would like to see more of the MEMS sensors. Because
Oh,
this
nice.
is something which I feel. This is just my you know how I can say it's just I think should be intuitive.
Brandon, I
Okay.
have one topic to add in your list. We have a lot of people who do some contract design. So a case like Ahmed, the case like Pallav, a lot of these people who are like a professional engineers, but they source their expertise, right? And because you've been coming from this background where you have extensive connections, why not we have one day to invest in how to choose and refine the sensors that requires to your IoT design? Because choosing right sensor, understanding, having the knowledge of analog and digital sensors and the pricing and how to approach to get the field application engineers, all this, these are like a little bit, I think, the application side of the communication. Maybe because I remember once Ahmed and I had this discussion that he had a requirement where he has very limited time to choose a particular sensor or the hardware for his project. Maybe that will be the wider interest of the entire community, because no product can be built without sensor selections and approaching those companies. Sometimes those companies are very difficult to approach. Those are, you know
So
number
my
one is how to search those, then how to approach and convince them to share information. Yeah.
So my question would be, okay, what kind of sensors? Because there's all sorts of different kinds of sensors, and that would help steer me. I know a guy pretty well over at Bosch Sensor Tech, who I think might be a good candidate for this. But there's a couple things to consider here. Number one, what you described is a really huge topic, right? It's like
Yeah,
that's
we
one of
can break down.
yeah.
Yeah.
So we'd have to break it down, but it would be nice to have something ongoing. Number two is Bosch Sensor Tech. I don't know if any of you are familiar with them. Most of the sensors they make are like
Reutlingen, Germany, Reutlingen. I visited
so,
the plant in 2011, Reutlingen, Garlingen. So it's a big, huge Bosch sensor tech. I worked on their mirror assembly. They were developing some optical sensors back in 2010.
mhm.
Yeah.
Yeah. They're so they create MEMS sensors, right? And MEMS are used in a lot of if even consumer electronics. But I just want to make sure that we are clear that we're talking about that type of sensor, instead of some huge industrial flow meter or whatever.
I have a point there. Like, why not we take this topic and cut them into pieces? Like, let's say when we talk about sensors for consumer electronics, we talk about consumer electronics sensors, right? No need to talk about IFM sensor or
Right.
sensor tech from Bosch, sensor tech or something. Those are very expensive and high end. Maybe in that case, we are talking about to help the people who do contract designs, right?
Yeah.
And those are the people usually have a very tight deadlines, and they don't get a project where they are building sensor system, control system for the boiler or nuclear reactor or something. They're just having product which is consumer focused, or maybe even if industrial IoT, it will be very low end, right?
Right.
So, and later maybe we can go for high end sensors, but not now.
Yeah. Okay. I'll reach out to Marcelino and see if he or somebody on his team can come, give us 15, 20 minutes just of like general overview and, how they would prescribe selecting sensors and, what the common interfaces are, because there are actually some new interfaces that are like sensor specific, like I3C. I don't know if any of you guys have heard of that.
Yeah.
But those would be some pretty good topics to go over. So it probably will not be in the next week, to be honest, just because we're getting so close to Christmas and stuff. But I'll put that on my to-do list.
Yeah. Just I thought maybe I will forget in future, so let's just put this out.
Yeah. Okay. Thanks for that. All right, y'all. Well, we're 15 minutes past the top of the hour. Is everybody or the people here going to be available next Friday? I mean, I'm going to make myself available next Friday for this. If you're all going to be free, then great. If not, then have a Merry Christmas if you celebrate.
I will be there on Friday. I have no problem.
Yeah, I will be
Likewise.
also there.
Cool. All right, guys. Well, thanks so much for participating. Is that the last slide, Navdeep?
Yeah, I did.
Dude, good job. I really appreciate it. Thank you.